Welcome to this video. So in this video, we are going to look at questions from test 1. This is A-level mathematics, okay, for the students that are doing A-levels at the University of Lusaka. So this paper has about 25 questions, and I'm going to solve all of the 25 questions. Okay, I'm going to explain how you can get their answers in a very simple way. All right, so these questions are on different topics, okay, but they are very, very practical, okay. So it will be a situation where they are referring to a certain situation that you can have in the medical field, okay, like how to determine maybe how a virus is going to spread, okay. So they are very practical in nature, but we are going to be applying the same mathematical concept that we learned, okay, like finding the maximum value of a quadratic equation, okay. There are questions on probability, all those things, okay. So there are about 25 questions in this paper, and I'm going to solve each and every one of them, okay. So please enjoy this video. So let's start with question 1. Okay, let's start with question 1. So question 1, they're saying, in some controlled biological system, the concentration levels of a specific mRNA transcript denoted by LN follow a repeating pattern over successive replication cycles. The first few concentration levels are coded as follows. Okay, so we have our L1 being equals to 1, L2 being equals to T, and then L3 being equals to T to the power, T to the power 2. Okay, and then L4, we have it as T to the power 4, and then L5, okay, L5, we have it as 1 again. Okay, so they're saying where 1, this one here, represents a baseline expression level when the transcription is at a steady state, and T is a transcription efficient factor influenced by mRNA polymerase, okay, activity, transcription factors, or mRNA stability. Okay, given this pattern, determine L925. Okay, that is the concentration of the mRNA transcript at the 925th replication cycle. So at the first replication cycle, we have the value 1. At the second replication, we have the value t. The third replication, we have the value t squared. The fourth one, we have the value t to the power 4. And then when we go to the fifth one, okay, we notice that the pattern restarts. Okay, so remember they said this follows a repeating pattern over successive replication cycles. So it means that this pattern is going to be repeating every after 4 cycles. Okay, because that's what we can see from what we've been given here. It was 1 t squared, t to the power 4, and then it's back at 1. So meaning if I want to find L6 will just be t. Okay, L7 will be t squared, and then L8 will just be what? T to the power 4. And then here, if I come back now, L9, this L9 will just be 1 again. L10 will be T. L11 will be T squared, and then L12 will be what? T to the power 4. So this pattern will continue. So if I had to find L13 here, the L13 will just be 1. Okay, L14 will be T, L15 will be what? T to the power 2, and then L16 will be T to the power 4. Okay, so that's how you can find the values at the replication cycles. Okay, so now the problems comes in. Okay, the problem comes in when you are given a very large number. Okay, for example, this one here. How do we find L9 25? Okay, how can we find this one? That's where the problem comes in now. So you can't manage to write L following this pattern until you reach L925. No. Okay, it's impossible. So what we have to do is identify a pattern that is being done here. Okay, so to find this L1, okay, what did they do? Okay, so remember, we said the patterns that are repeating are how many? Okay, we see that 1, 2, 3, 4. So the pattern that are repeating are 4. or we can say the replication cycles repeats every after what? 4 cycles. Okay, the replication repeats every after 4 cycles. So how are they finding this one here? This one is found by simply dividing, okay, the replication cycle, the number of the replication cycle by the repeating cycle, and then getting its remainder. Okay, so how did they find this L1 is equals to 1? They got this replication cycle, which is 1. Okay, and they said 1 divided by the number of cycles, which is 4. It's going to give me 0. Remainder what? 1. So this one, the remainder, is the one that they put here. So let's see if it will work here. So it will be 5 divided by 4 is equals to what? Okay, how many 4s are in 5? It is 1. And then you have a remainder 1. No wonder here L5 is also equals to what? 1. Okay, does it still work if I have L9? So L9, okay, L9, it means it will be 9 over 4. So how many 4s are in 9? It is 2. Remainder what? 1. So this remainder is the one that you write there. Okay, I hope we are following the pattern. What about 13? So it will be 13 over 4. This will give me 3, remainder what? 1. So this remainder is the one that they put there. Okay, so it means if I want to find the L925, okay, if I want to find L925 here, what I have to do is get this number, 925, divide it by what? By 4. Okay, and then see if its remainder, uh, we are going to get its remainder. Okay, so 925 divided by 4. Okay, it's going to give me what? Okay, it's going to give me 231, remainder 1. Okay, so this remainder 1 is the one that you write there, remember? Okay, so we're going to say L 925 is simply equals to what? 1. Okay, why? Because this is just a repeating pattern over successful replication what? Cycles. So the number of cycles are 4. Okay, and then you get the value that you've been given, you divide it by 4, and then the remainder will be the answer for that what? For that cycle. Right, so that's how you find the L925 here. So L925 is simply 1. All right, let's look at question 2. So question 2, what are they saying? They're saying at a certain specialist cancer hospital, the probability of having a cancer operation done depends on the availability of a specific specialist oncologist. Okay. From past records, the hospital notes that the probability of having this specialist at the facility is 0.51. If around, the probability that the hospital authorizes a cancer operation is what? 0.83. And if not around, the likelihood reduces to this much. So this is the probability that the hospital authorizes a cancer operation if this specialist is not what? Around. Okay. Then it continues to say, find the probability that the hospital authorizes a cancer operation and this specialist is not around. Okay, so here we have a series of events that we need to give some symbols so that our solving becomes simple. So let's say, let A be the event that the specialist, okay, is what? Around. Okay. Okay, specialist, what am I writing now? Okay, specialist is around. Let A be that. Okay, and then let A complement be that the specialist, okay, is not around. And then also, okay, let's have that authorizes a cancer operation. Okay, so let's say B is that the cancer operation is authorized. Okay, cancer operation is authorized or allowed. Okay, and then let B complement be that the cancer operation, okay, is not authorized. Okay, so we've named our events. Okay, we've named our events, and it will be very easy for us to calculate the probability. So let's go back to the question and check what we have. So remember, they said from past records, the hospital notes that the probability of having this specialty at the facility is 0.51. So meaning the probability of A is actually what? 0.51. Okay. And then it means we can find the probability of this specialist not being there, because we know that the total probability is always equals to 1. So the probability that is there plus the probability that is not there should always be equals to what? 1. So we're going to say probability of A complement, meaning is not there, will just be 1 minus 0.51. Okay, so what will this give us? If I subtract, it to be 0.49. So this is the probability that this guy is not there. Okay, what about the probability that the cancel operation is authorized? Okay, so here they said what? Okay, so here they didn't give the exact value of this probability. Okay, that the cancel operation is allowed. Instead, what they gave us, okay, was the conditional probability. So if you read it, it is if this specialist is around, the probability that the hospital authorizes a cancer operation is this. So this is a conditional probability depending on the availability of the what? The specialist. So it's the probability, okay? It's the probability of authorizing the operation, I mean, which is being indicated by B, given that, okay? Given that the specialist is around, it was given as a 0.83. Okay, so what else can we find from this? Okay, if this is a probability that the operation is authorized, given that this guy is around, okay, how can we find the probability, okay, that this operation is not authorized, given that the specialist is around? Okay, so we just subtract, okay, 1 minus this. Okay, so 1 minus 0.83 is going to give me 0.71. Okay, what other probability were we given? This one here. Okay, let's read it and understand it. So the other one is that they said if okay, if around the probability of that the hospital authorizes the cancer operation is this, okay, and if not around, the likelihood reduces to this. So what does that mean? It means the probability, okay, of authorizing of an operation if the specialist is not around. Okay, given that the specialist is not around, it's the one that we are given there, which is 0.44. So we can also calculate from here, okay, the probability that the cancer operation, okay, is not authorized, given that the specialist is not around. So it will just be 1 minus this. Okay, so 1 minus this to give me 0.56. Okay, so these are the probabilities that I can get from my data there. Okay, so now if we go back to the question, they're saying find the probability that the hospital authorizes a cancer operation and this specialist is not around. Okay, so we know that in probability, the word and means intersection. So authorizes a cancer operation, specialist not around. So authorizes, we said this was B. Is not around, we say it was A complement. So the probability that we are finding here is simply B intersection what? A complement. So how can we find this given this data that we have here? Okay, so we are going to use the formula for the conditional probability. Okay, so if I have X and Y, okay, if I'm finding the probability of X given Y, this here is the same as the probability of X intersection Y divided by the probability of what? Y. So to find this, I'm going to use something similar to this. Okay, we're going to find the probability of A. I mean the probability of the probability that the operation is allowed okay, or it, okay, we're going to find the probability that the operation is allowed given that the specialist is not what? Is not around. Okay. Okay, so to get this probability, we are going to use the conditional probability, okay, that the operation is authorized, okay, given that the specialist is not allowed. Okay, but this, uh, but this expression here can also be made into this form. Okay, so let's put it in that form. Okay, so we're going to say probability that the operation is allowed, given that the specialist is not around, is equals to the probability, okay, of B intersection A complement, which is what we want to find here, okay, divided by the probability of what? Um, Divided by the probability of A complement. Okay, so this follows from the formula for what? Conditional probability. Okay, I hope no one is lost there. So here we want to find this because we don't have it, but we have this and we also have this. We can check what we have here. Okay, so the probability of this, we have it there. The probability here, we have it there. So we can use those. So we're going to say this one divided by 1, cross multiply. So probability that B intersection A complement is equals to probability of A complement multiplied by probability of B given A complement. Okay, so that will be our desired probability there. So now let's just substitute the values there. So probability that the hospital authorizes the cancer operation and the specialist is not around is equals to the probability that the specialist is not around, which is 0.49, multiplied by the probability that the hospital authorizes the cancer operation, given that the specialist is not around, which is what? 0.44. Okay, so when we multiply this, we get 0.2156. We can round off to 2 decimal places, so it will be 0.22. Okay, so this here is the probability, okay, that the hospital authorizes a cancer operation and the specialist is not what? Around. All right, so that's how we solve question 2. Let's go to question 3. Okay, so on question 3, you're just playing with the minimum here or the turning point. Okay, so let's read the question. So they're saying, a pharmaceutical company plans to begin production of new antibiotic drugs to effectively treat a particular bacterial disease that has developed new strains. For these drugs, each tablet is designed in the shape of a solid circular cylinder with base radius x milliliters, okay, x millimeters, and height h millimeters, whose surface area is given by this, where A is measured in squared millimeters. Okay, so if the manufacturer wishes to minimize the surface area of each tablet, find the value of x for which x is minimum to 2 decimal places. Okay, so for us to find this value of x for which this A is minimum, we just have to find the turning point. Okay, and we know that at the turning point, the derivative of whatever function we have is always what? 0. Okay, the derivative is always 0. So if I have A is equals to 2 pi x squared plus 46 divided by x, okay, this is the same as 2 pi x squared plus 46 x to the power minus 1. Okay, so I want to differentiate this with respect to x. So it will be dA dx is equals to, okay, this power multiplies whatever is in front of the x, so it becomes 4 pi, and then it reduces by 1. So this will be pi x, and then this one, the minus power, multiplied with the 46, x, and then it reduces by 1, so it will be minus 2 now. Okay, and then okay, that's basically what we have there. Okay, so it means this one is our derivative, or our dy dx, or our gradient, okay, or the value at the turning point. Okay, but we know that dA dx at the turning point is always what? 0. So for us to find the value of x for which a is minimum, okay, we just have to equate this guy to 0, and then so for x. So it will be pi. What has happened to my pen? So it will be 4 pi x minus 46 over x squared now. Okay, remember this was to the power minus 2. So the minus 2 can go into the denominator like that, is equals to 0. So I want to find the value of this x. Okay, so it will be 4 pi x is equals to 46 over x squared. Okay, what do we do with this? We say cross multiply. We have 4 pi x to the power 3 is equals to 46. Okay, then we can divide both sides by 4 pi, even this side by 4 pi. So it will be x to the power 3 is actually equals to, okay, 23 over 2 pi. Okay, so 2 pi. So I just divided this 46 by 2, I get 23. This 4 pi by 2, I get 2 pi. Okay, and then now you can find the cube root of that. Okay, you use your calculator there. So we're going to say x is equals to the cube root, okay, because here we have cube root. So if I introduce a cube root here, the power 3 goes. So cube root of 23 over 2 pi. So you can punch this onto your calculator. So it's giving me approximately 1.54. So I'll just leave it to 2 decimal places like that. Okay, because here they said 2 decimal places. So it means at x is equals to 1.4, the area will be what? At its minimum. All right, so that's how we solve question 3. Let's look at question 4. Question 4, they're saying a doctor is studying the spread of a virus in a population and models the number of infections over time using this quadratic equation here. Okay, so they're saying IT represents the number of infections at time t in days. What is the maximum number of infections and on which day does it occur? Okay, so here it's just the quadratic equation that is being very practical. Okay, they are just simply asking you to find the turning point. Then you state the x coordinate of the turning point will be the day. Okay, and then the y coordinate of the turning point will be what? The number of infections. Okay, so our quadratic equation has been given in this form: minus t squared plus 14t plus 8. Okay, so this is our quadratic equation. So we simply find the turning point. Okay, so if you want, you can use completing the square method to find the turning point, or you can just simply use the formula. First, you find the x coordinate of a turning point. Okay, but in this case, since this quadratic equation has been given in t, okay, so we are going to say t is equals to minus b over a. Remember, this is the x coordinate of a turning point. If I have ax squared plus bx plus c, okay? If I want to find the x coordinate of a turning point here, I said x is equals to minus b over 2a, remember? Okay, and then the y coordinate of a turning point will just be f of minus 2b over a. Okay, that's what we said. But here, this quadratic equation is in form of t. So we're going to say t is equals to this. Okay, so we can get our a, our b, and our c from here. So what is our a? Our a is minus 1. So always the coefficient of the variable that is squared. So t squared, its coefficient is a. Okay, and then b is the coefficient of t, and then c is just the constant here. So this will be equals to minus b, which is 14, divided by 2 multiplied by minus 1, which is a. So this will be minus 14 divided by minus 2, which will just be what? 7. Okay, so the number of days there will just be 7 because this one is acting as the x-coordinate of a turning point. And then what is the maximum number of infections? Okay, we just find the I of 7. So it will be minus 7 squared plus 14, 7 plus 8. So this will be equals to, okay, so minus 7 squared there. We're going to get what? Okay, so you can use your calculator there. So 7 multiplied by 7, so there to be minus 49 plus 14 multiplied by 7. That will be plus 98 plus 8. So you can add this. So you say 98 minus 49, then plus 8. I'm going to get 57. Okay, so that's it's acting like the y-coordinate of a turning point, which indicates the maximum. Okay, so the max number, we're going to say is equals to what? 57 infections. And then on which day? Okay, on which day we're going to say day 7 or the 7th day. Okay, which is a very important day for the SDAs, right? Okay, so that's what we can do there. Okay, let's look at question 5. So question 5, they're saying a hospital gives awards. Okay, a hospital gives awards to its intern medical staff based on their levels of courtesy and punctuality. The probability that an intern, okay, the probability that an intern gets gets a courtesy award is 0.32. The probability that they get a punctuality award is 0.21. And the probability that they get both awards is this. Okay, find the probability that an intern will get at least one of the two awards. Okay, so we'll say let the event that they get a courtesy award be A, and then let the event that they get an award for punctuality be B. Okay, so now, according to what we've been given, okay, the probability of getting a courtesy award is 0.32. The probability of getting a punctuality award is 0.21. And the probability of getting both, so both is just means the intersection, okay, is equals to 0.15. So now what they're asking us is find the probability that an intern will get at least one of the awards. Okay, so you can get just one, like for the courtesy, and that's all, or you can get just one for the punctuality, or you can get both. Okay, that's what it means to be at least one. So one or more. So we're finding the probability that this intern gets A or B. Okay, so this probability is the same as the probability of A union B. We know that in probability or in set theory, O means union. So we're just finding the probability of A union B. Okay, so the probability of A union B, okay, remember the total probability, okay, if you're given two sets, will just be probability of A plus probability of B minus probability of A intersection what? B. So it means what we have here, probability of A is 0.32 plus probability of B minus probability of both. So this will be equals to, okay, this will be equals to 0.38. So this is the probability, okay, that the intern will get at least one of the two awards, meaning you won't get 0 awards. Okay, you will get one or more. All right, so that's that. And then question 6, we're still on this page. Question 6, they're saying refer to the scenario in question 5. Okay, find the probability that an intern will get only one of the two awards. Okay, so what does it mean getting only one of the two awards? It means that if he gets the award for A or for courtesy, is not going to get the award for B. Or the other way, it means that if it gets the award for punctuality, then it's not going to get the award for what? For courtesy. Okay, that's what it means to find the probability that the intern will only get one of the two. So probability that only get, okay, only one of the two will be equals to the probability, okay, that it gets the award for courtesy intersection that it doesn't get the award for what? For punctuality. Or it can be plus the probability that it doesn't get for courtesy, but it gets for what? Punctuality. So this is the probability that only one of the two. Okay. But what is this? Okay, because we don't have it on the values that have been given here. What is this? So I'll draw a Venn diagram to illustrate this. Okay, so this one here is the same as the probability of A minus probability of A intersection B. Okay, and this one is the same as, okay, this one here. It's the same as the probability of B minus probability of A intersection B. But how do we move to this, or that to that? So you draw a Venn diagram to understand. Okay, so I'll need some space here. So if this is the Venn diagram that we have, okay, this is my B, this is my A, right? Okay, so remember we have A intersection B complement. So A is everything here in this set A. Okay, but we are just intersecting this A with the part of the B complement. So the B complement is this part that I'll shade in red. So everything that is outside B, that's the B complement. All this part here is the B complement. Okay, so I want to intersect this red part, okay, with, let me choose green. I want to intersect this red part with the green part. Okay, so the red part is indicating all the values that are outside B. Okay, and then the white part or the green part will be indicating all the values that are in A. Okay, so where do the green lines and the red lines meet? Okay, so that region, we'll see that it will just be this part here that I'm tracing in white. This part here. Okay, that's the region where you can see both red and what? Green lines. Okay, so if we are to shade this on the Venn diagram, to just be this part here that I've traced in what? In a white. So if I want to find the probability of this thing that I've traced in white, it's the same as finding the probability of this whole set A, which is what I wrote there. And then I say minus the probability of this part here. Okay, so now the probability, okay, the probability of this part here. What is the probability of this part? Because this here is just simply A intersection B. So the probability of this part here is just simply A intersection B. And it will be the same thing when you look at this scenario here. So you shade outside A and then you shade inside B to just be this part. So if I want to find the probability of this part here, to just be the same as the probability of this whole set B minus the probability of what? Their intersection. No wonder we are coming up with these things there. Okay, and then from there now we can find our probability. Okay, because we have these values here. So the probability of A is simply 0.32 minus the intersection there. Its probability is this one, 0.15, plus the probability of B, which is 0.21 minus 0.15. Okay, so that's what we have there. So we can write this and this, we can combine them. So it will be equals to 0.32 plus 0.21 minus 2, 0.15. So just get your calculator. We punch these values. We see what we are going to get. I'm getting 0.23 as my answer. Okay, so we are done with 6 or part 6. So now let's look at part 7. So part 7, they're saying what? They're saying, refer to the scenario in question 5. Find the probability that an intern will get no punctuality award given that they have gotten a courtesy award. So this is a conditional probability. So probability that they have not gotten a punctuality award. So punctuality award, we said it was B, but they have not gotten it. So it's B complement, given that they have gotten a courtesy award, which is represented by A. So we're finding this conditional probability, which will just be probability, okay, of what? Have I interpreted it correctly? Okay, let me read it again. So refer to scenario. Find the probability that an intern will get, okay, will get no punctuality award, okay, given that they have gotten a courtesy award. So it's a B complement given A. Okay, yeah, I'm correct. So this one now, when we expand it, it will just be what? Okay, it will just be B complement intersection A, or we can write it as A intersection B complement. It will still be the same. Then divided by the probability of what? A. So now this one on top from the previous question, okay, we say it's the same as probability of A minus the probability of A intersection B. Then this we divide by the probability of what? A. So now we have these values, okay? So probability of A is 0.32 minus probability of A intersection B, which is 0.15, divided by the probability of A, 0.32. So calculator, I'm getting 0.53. So this will be the answer there on question what? 7. All right, so we go to question 8. So question 8, they're saying, let y be equals to this, be a polynomial given by this. Okay, polynomial given by this. So they're saying find solution sets, okay, for which f of x is greater than 0 and f of x is less than or equal to 0. Okay, so for us to get that answer there, we need to sketch this polynomial here. Okay, and we know that for us to sketch a polynomial, we just have to factorize it completely. Okay, so we express it entirely in terms of factors. Okay, and then those factors are going to give us the points where the curve is going to touch the x-axis, okay, going to touch the x-axis, and then we can sketch it. So how do we factorize a polynomial? Okay, we use try and error method. Okay, so let's try the factor maybe 1 plus 1. Okay, so we want to see if this is a factor of this. So if this is a factor of this, then when I replace, okay, when I do x plus 1 is equals to 0, x is equals to minus 1, okay, if this is a factor, then if I substitute minus 1 wherever there's x here, I should get 0. So I'll say f of minus 1 is equals to minus 1 to the power 4 minus 6 minus 1 to the power 3 plus 9 minus 1 squared minus plus 4, minus 1 and then minus 12. So this will give me here, because the power is even, okay, the answer will be positive. So if you have a negative number there, just look at the power. So if the power is even, you're going to get a positive number. If it's odd, you're going to get a negative number. And then this will be minus 6 here. And then this minus 1 to the power 3. 3 is odd, so I'm going to get minus 1 here. So minus 1 multiplied by this, I'm going to get plus 6. Here, the power is even, so I'm going to get positive. Okay, so it will be positive 9. And then here to just be minus 4, minus 12. So does this give us a 0? Okay, so we try to add. So this plus this is going to give me 16. So 1 plus this 16 minus 4 minus 12, it's also 16. Okay, so this one works. So it's equals to 0. So we have established that x plus 1 is a factor of this guy here. Okay, so it means we can use a synthetic method to reduce that polynomial from power 4 to power 3. And then we use the trial and error method again to find another factor so that we reduce that polynomial to a quadratic, and then we can simply factorize a quadratic. Okay, so from here, I'm going to get x is equals to -1. So I'm using synthetic method. So just get the coefficients of this, and they should be dropping down nicely there. So the coefficient of x power 4 is 1, power 3 is -6, power 2 is 9, power 1, which is just for x, is 4, and then power 0 is -12. Okay, so I drop this one, and then I say plus, so 1 is there, so -1 multiplied by 1, I get -1. If I add, I get -7. Okay, -1 multiplied by 7, I get 7. If I add, I get 16. -1 multiplied by 16, I get -16. If I add, I get -12. -1 multiplied by -12, I get +12. Here, I get 0. So indeed, this one is a factor because you have to get remainder 0 there. So it means now, from this power 4 polynomial that we have, okay, once we divide it with one of the factors, it reduces to what? Power 3. So this one here are just the coefficients of the polynomial that has reduced to power 3. So this will be power 3, power 2, power 1, constant. So it will be x to the power 3 minus 7 x squared plus 16x minus what? 12. Okay, so it means this guy here has simply reduced to this. This guy here is the same as the x power 1, the factor that I divided with, and then I write this x to the power 3 minus 7x squared. To remove this, okay, minus 7x squared plus 16x minus 12. So this is what we have there. Okay, so from here, we test factors again on this expression that has the power 3. Okay, so it's just a trial and error. Okay, so let's try x minus 2. So this will mean my x is equals to what? To 2. So if I substitute 2 there, will it give me 0? So I'm going to say f of 2 is equals to 2 to the power 2 minus 7, 2 squared plus 16, 2 minus 12. So this will be 8. Okay, 2 to the power 3 is 8. Here to be minus 7 multiplied by 4, which will just be minus 28 plus 32 and then minus 12. Okay, so this one here is going to give me minus 20. 32 minus 12 is going to give me plus 20. Okay, so it means this guy is a factor there. So x minus 2 is a factor. So let's divide this using synthetic division using this factor. Okay, because this minus 20 plus 20 will give us a 0 here. Okay, so it's a factor. So using synthetic division, I'm going to say 2. Okay, when we equate this to 0, it's going to give us 2. Then we get the coefficients from this polynomial here. So it will be 1 minus 7, 16 minus 12. So we drop down the 1 to be 1. 2 multiplied by 1, I get 2. When I add, I get minus 5. 2 multiplied by minus 5, I get minus 10. When I add, I get 6. 2 multiplied by 6, I get 12. When I add, I get 0. Okay, so that indeed is a factor. So we have reduced now from power 3. Okay, this one will be power 2, power 1, constant. So it will be x squared minus 5 plus 6. Okay, so this is the polynomial that we are left with. But the quadratic equation, okay, we can just simply factorize it using what? Factors. Okay, so we're going to say product factor sum. So the product is 1, the coefficient of x squared multiplied by the constant, which is 6. The sum is minus 5. So which two numbers, okay, can I add to get minus 5? But when I multiply, I get 6. It is minus 3 and minus 2. Okay, so this will be equals to x minus 3 and x minus what? 2. So this is what I have. So from this, I have these factors. Remember, this is a factor and x plus 1 is a factor. Okay, so it means the f of x, okay, this function here, f of x, I can simply write it in terms of its factors. So it will be the first factor, x plus 1, the second factor x minus 2, but x minus 2 appears twice because I have it here and I also had it there. So it will be squared and then x minus 3 there. Okay, so we have written the polynomial in terms of its factors. So once we have it in its factors, then we can simply sketch it. Okay, and then after sketching, we can now find the values for which f of x is greater than 0, f of x is less than or equal to what? To 0. So if I equate this factor here to 0, I'm going to get x is equals to minus 1. If I equate this one, I'm going to get x is equals to 2. If I equate this one, I'm going to get x is equals to 3. So these three values here will be the critical values on my sketch. Okay. Okay, the critical value simply means the points where the curve is going to be touching the x-axis. Okay, but there are two types of touches, okay, that the curve can make with the x-axis. So one, it can cross the x-axis, and then two, it can bounce. So what happens for it to bounce? So if this is my x-axis, right, I have maybe A here, B, then C. So the curve can come like this and cross here. Okay, and it can also come here and cross, but sometimes it will bounce back like that. It wants to cross this point. So why doesn't it cross this point? Okay, you look at the power of that factor. Okay, you could look at the power of that factor. So if the power is odd, okay, like this one here simply means this is power 1, even this one is power 1. So if the power is odd of that factor, then the curve will cross the x-axis at that point. Okay, but if the power is even like this, okay, like if it's 2, 4, 6, 8, okay, if it's even, then it means at that point the curve will not cross it like this, but it will bounce and then to go back to the direction where it came from. So that's the scenario that we're going to have there. So at minus 1, it's going to cross. At 2, it's going to bounce. At 3, it's going to cross. Okay, why? You look at the multiplicity there, or the power on the factor. So if I were to draw this, or I were to sketch it, this is my y. This will be my x. Okay, so I have 0 there, and then minus 1. I can have 2 there, and then 3. So just plot these three factors. Okay, so where can I start my sketch now? Okay, do I start my sketch from down here, or do I start it from up here? Okay, so what will make sense is the one that I start from down here, because if I start from up, it will come like this, cross here. Okay, and then to come here, it will bounce here, right? Okay, it has to bounce here. Then how does it go back and pass through? Yeah, so this one actually makes sense. So the one that comes from down here and goes like that is the one that does not make sense. Because if it comes from down, okay, it means that I'm going to have something like this. Then here it will bounce at 2. Remember the power is 2 there. So it will bounce here and then it will go like this. So it means it won't pass through this. But according to the question, this is one of the points where the curve should do pass. Okay, so it means the only logical way, okay, in which this can move is that it will come like this, and then it will go like that, bounce there, then it will go back, and then it will pass there. Okay, so you can see these points here, this one, and this one. Okay, so if it has a power 2 like this one, it will bounce like that, you've seen. Okay, so now after we sketch this, because this is our f of x, after we've sketched it, okay, after we've sketched it, we can now find, okay, the solution set for which f of x is going to be greater than 0, f of x is going to be equals to or less than 0. So f of x is greater than 0. Okay, the solution set is simply all the x values such that the graph is above the x-axis. So the graph is above the x-axis, starting from this point going to the left, and starting at this point going to the right. It's above this blue line here is above the x-axis like that. Okay, so we have two solution sets for this case here. So let me erase this part. Okay, so for the case f of x is less than 0, we have two solution sets. Okay, one of them is that x is less than, what is the value of x here? It's minus 1. So if x is less than minus 1, then the curve will be above the x-axis. This blue line here will be above this x-axis in yellow. Okay, and then we're going to say, or x should be greater than what? 3. So at this point 3, above, okay, for all the values that are greater than 3, this blue line will be above the x-axis. Okay, so that's the case for f of x is greater than 0. Okay, so this is the solution set. And then for f of x is less than or equals to 0, it means we want the x values such that the graph is below the x-axis. So the graph is below the x-axis, okay, starting at this point all the way to this point. It's below. You can see this blue line here. It's below the x-axis, okay? So it's from here all the way up to there. So how can we represent that interval? Okay, we're just going to say -1 greater than less than or equal to x less than or equal to what? To 3. So between 1 and 3, the graph is down there. So it means the f of x is less than or equal to 0. And then the f of x is greater than 0 if the x is less than -1, or the x is what? Greater than 3. All right, so that's how we can answer that one. We look at question 9 now. So question 9, they're saying a medical researcher is studying how a sedative is absorbed into the bloodstream from the stomach. The rate at which the drug enters the bloodstream is modeled by this equation. So now this equation, you notice that it's a derivative because here they've given us a prime like that. Okay, so if I have f of x, the derivative of f of x is f prime of x like this. So it means this one is a derivative of a certain function, which is what? A of t. Okay, so here they're even telling you that a prime of t is milligrams per hour, and t is the time in hours after the administration of this drug then enters that enters the bloodstream. So the question now comes, if the initial amount of the drug in the bloodstream was 12 milligram, how much is present after 4 hours? Okay, so the initial simply means when the time was what? 0. The initial A of 0 was equals to 12. Okay, so how much is present after 4 hours? So to find how much is present after 4 hours, we first have to find this function A of t. Okay, so it means here we have to integrate this derivative that we've been given. So I'm going to say A of t is actually the integral, okay, of a prime of t, which is just 6t plus 3t squared with respect to t. Okay, so if I integrate this to be 6t squared over 2 plus 3t to the power 3 over 3 plus c, because this is not a definite integral, so you always have to put plus c there. So this is my A of t. Okay, and then we are told that at A0, when the time is 0, okay, our A of 0 is equals to 12, which will be equals to, so wherever there's t here, I'm going to put 0. So this one here is 6 divided by 2, so that is 3, and then 0, plus 3 divided by 3 is just t to the power 3, which is 0 to the power 3, plus c. Okay, so we end up with 12 is equals to 0 plus 0 plus what? C. So it means C is what? 12. Okay, so for us to find our function A of t, it will just be this function, and the value of C there of found it is what? 12. Okay. Okay, so we're going to say A of t is actually equals to 3t squared plus t to the power 3 plus the constant, which is what? 12. So now, how much is present after 4 hours? This will just be A of 4 now. So 4 squared plus 4 to the power 3 plus 12. This will give us what? Okay, so this will be 16 inside multiplied by 3 to be 48 plus 4 to the power 3, it's 64 plus 12. Okay, so 48 plus 12, that would be 60. 60 plus 64, that would be 124. Okay, so the amount present after 4 hours will just be 124 milligrams. Right, let's look at the last question for this video. So they're saying here, a medical team maps a disease outbreak zone using a circular uh, detection radius. The danger zone is modeled by this equation here, which is just the equation of a circle with the center 5, comma, minus 3, of course. A mobile clinic sets up a protective boundary that is tangent to this zone. If the boundary line has a gradient minus 3, which of the following gives the possible equations of the clinic's boundaries? Okay, so it means we just have to find the equations of the tangent line. So it's like the danger zone, it's in form of a circle like this, right? Okay, and then they're saying to this circle, there's this tangent line that touches this circle at one point like this. So this is the tangent. Okay, but again, this tangent, we can also draw it this way, like that. Okay, that is also the tangent. So they're saying this circle has the center at 5, comma what? 3. Okay, so from the center to the point where the tangent line touches the circle there, okay, these two lines will be perpendicular, or they will meet at right angles. Okay, so this line here now is called the normal line. Okay, because it meets the tangent at 90 degrees. So we've been told that the gradient of this tangent line, if you want, we can use this one. Okay, it will just be the same. The gradient of this one, I'll say M1 is equals to minus 3. Okay, so using this one, we can find the gradient of this normal line here. So the gradient of the normal line, we know that M1 multiplied by M2 is equals to minus 1. So M2, which is the gradient of the normal line, will just be minus 1 over gradient of the tangent. So this will be minus 1 over minus 3, which will just be 1 over 3. So the gradient of this, we say M2 is equals to 1 over what? 3. Okay, so after we find the gradient, okay, of this normal line, then we can find the equation of the what? Of the normal line. Okay, we can find the equation of the normal line. So let's find the equation of this normal line here. Okay, so why are we finding the equation of the normal line? So that we can solve it simultaneously with the equation of the circle, so that we find the points, okay, where the tangent will meet this circle. So we are interested in this point. So we can find this point by the intersection of this normal line and this circle here. And then even on the other side there, we also have a normal line there, like that. So if we also want to find the coordinates of that, okay, remember the gradient of this is still what? Minus 3, because this line and this line will just be parallel. Okay, so the line of this normal line will be in the form y minus y1 is equals to m x minus x1. So y1 and x1 will be gotten from this point here. Okay, remember this normal line passes through the center, which is 5, 3. So it will be y minus 3 is equals to the gradient of this. We found it was 1 over 3, and then x minus 5. Okay, so it means what will be our equation to just be y is equals to this. I multiply with this minus 5 over 3. Then this here will be plus 3. It goes to the other side to be minus 3. Okay, so we can add those. So we can add this part here, or we can subtract it. But since same sign, so we can add it. So minus 5 over 3. Okay, we can also make this to have a denominator of 3. So it will just be 9 over 3. So this will be minus 14 over 3. So it will be 1 over 3x minus 14 over 3. So this is the equation of this normal line here. Okay, so once I have the equation of a normal line, I can solve it simultaneously with the what? The equation of the circle, so that I find the points that I'm talking about, this point and this point. Then once I have this point or that point, I can use this gradient and this point to find the equation, this gradient and this point to find the equation. That's all. Okay, so let's solve those things simultaneously now. Okay, so wherever there's y in the equation of a circle, I'm going to replace with this. So it will be x minus 5 squared plus, wherever there's y, I'm putting this, so minus 1 over 3x minus 14 over 3. Okay, and then what else? And then plus 3 squared is equals to 10. Okay, so this will still remain what? So we can, okay, so x minus 5 squared plus, here I'm subtracting, okay, 14 over 3 plus 3, I mean, okay, it will give me what? Okay, so that one will just give me minus 5 over 3 squared is equals to 10. So now we can expand x multiplied by x squared, x multiplied by this, minus 5x multiplied by this, minus 5x. So I have 10x. 5 multiplied by 5, 25. Okay, so now how do I expand what I have here? Okay, how do I expand what I have here? Okay, so from there, I'm going to do this. I'm going to say plus this multiplied by itself, I get 1 over 9x squared. Okay, and then this multiplied by this, I'm going to get what? 1 over 3 multiplied by minus 5 over 3. I'm going to get minus 5 over 9. Okay, and then this multiplied by this, I still get this. So when I have 2 of these, so it's like 2 multiplied by this, so it will be minus 10 over 9x. And then this multiplied by itself, I'm going to get 25 over 9 is equals to 10. Okay, so now I want to eliminate all the fractions here. So I'm going to multiply throughout this by 9. So if I multiply everything by 9, I get 9x squared minus 90x plus, okay, 9 multiplied by 25. I'm getting 225. Okay, 9 multiplied by this, I'll just get plus x squared. 9 multiplied by this, I'll get minus 10x. Plus this, I'll get 25 is equals to 90. Okay, so now let's group like terms together. Okay, like terms together, this and this, they form 10x squared. This and this, they form minus 100x. And then now I'm remaining with what? 225, 25, and 90. So we can bring the 9 to the other side. So it will be 225. Okay, let me do this. Okay, so it will be 225 plus 25 minus 90, which will give me what? Okay, which will give me what? Okay, which will give me plus 160 is equals to 0. So this is the equation that we have, which is just a quadratic equation. So we can divide throughout by 10 to be x squared minus 10x plus 16 is equals to 0. So we can solve this quadratic equation. Okay, so what are the factors? Factors will just be minus 8 and minus 2. Yeah. So if I add this, I get minus 10. If I multiply them, I get 16. So if I factorize this, it will just be x minus 8 and x minus 2 is equals to 0. So x will be equals to 8, or x will be equals to what? 2. So remember, we had 2 parts where the tangent lines are meeting. Okay, so we can say here, that's where you have your x is equals to 2, and then there you have your x is equals to what? 8. So we need to find the corresponding y values there. Okay, so we're going to use any of the equations. If you want to use the equation of the circle, if you want to use if you want to use the equation of the normal line, I mean the normal line that we had found. Okay, so which I'm not going to use. Okay, so let's use okay, because this one here we have square, square, square. Okay, let's use the equation of the normal line that we had found. So the equation of the normal line that we had found was y is equals to 1 over 3x minus 14 over 3, I mean. So what is y if my x is 8? So if I put 8 there, to be 8 over 3 minus 14 over 3, which will just be 3. This one minus this is going to give me what? It's going to give me minus 6, which will just be minus what? 2. So if my x is 8, y is minus 2. So it means here, the point, this one here, to be 8 comma minus 2. And then what if my x is 2? What am I going to get? So if my x is 2, it will be y is equals to 2 over 3 minus 14 over 3, which will just be 3. 2 minus this, it is minus 12, which will be minus 4. So it means y there will just be what? Minus 4. So it means this point here is minus, it's 2 minus 4. Okay, so now we have the points and the gradient of these two tangent lines. Okay, so we can use that to find the equations. So the equations, I'll start with this one here. We're going to say this is the tangent 1, tangent 2. So tangent 1 be y minus the y coordinate here, which is minus 2. So it will be minus multiplied by minus. So it will be plus 2 is equals to, the gradient is minus 3, and then x minus the x here, which is 8. So the equation there will just be y is equals to minus 3x plus 24 minus 2. So it will be y is equals to minus 3x plus 22. So this will be the first equation. Let's find for tangent 2. Tangent 2 to be y minus the y value, which is minus 4. So it will be minus minus, that will be plus 4. Is equals to minus 3x minus 2. So this will be y is equals to minus 3x plus 6 minus 4. So this will just be minus 3x, okay, plus 2. So this will be the equation, okay, of the second tangent line. Okay, so this tangent line will give the boundaries of this what? Danger zone. So from here, from there, even if you found the tangent line in this case here, you're still going to find the same two equations. Okay, so that is going to indicate the boundary. Okay, so thank you so much for watching this video. In case you want to access the full video, okay, where I'll be solving all these other questions, starting from question 11 here, all the way up to, how many questions do we have here? All the way up to question 25. Okay, you are free to subscribe. Okay, you can find the link in the description of this video. You can subscribe, and then you find the full video to this test. Okay, even the test 1, there's also a video plus the tutorial sheet. So once you subscribe on our website, you're going to see something like this. So you can say open course. Okay, then you go to general mathematics. From there, you go to the past tests, quiz, and exam papers. Okay, so I'm going to upload that the full video in this folder here. So you are going to find it here. So that's semester 1. Okay, so video. So I'm going to upload it here. Okay, so the test 1 is already solved. This there. So once I'm done solving this test 2, it will just be somewhere here waiting for you. Okay, you can also access videos to all the tutorial sheets, okay? Because Dr. Msonda, Dr. Chideshi, and Mr. Chipoka, they just, for the exams, they just get questions, the same questions from the tutorial sheet. So if you come to the tutorial sheet folder here, okay, we have some videos for you and also written solutions. So this is semester 1. Okay, so if you go to video solutions, you're going to find the tutorial sheets there. So there's tutorial sheet 1, full video solutions, tutorial sheet 2, full video solutions, tutorial sheet 4, 5, 6, okay? And 7 and 8 will soon be uploaded here. So you can find them here. So if you go, for example, tutorial sheet 6 here, you're going to find the videos for the questions in tutorial sheet 6, which are these. So this was like on integration, something like that, differentiation. So you can use this to learn tutorial sheet 5. Okay, so just make sure for the exams, you solve all the questions in the tutorial sheet because they're just going to repeat those same questions. So if you're feeling lazy to solve the tutorial sheets, Those questions are going to haunt you. If you want, you can go to the written solutions here. We have the written solutions here. So 2025 here. Okay, so you can find them here. So 35 solutions, blah, 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 blah. So you can use all this to study. Okay. All right. So thank you so much. This has been Tutor Poor Solutions. Until next time, okay, feel free to contact me if you need any help in math or physics, chemistry, and biology.